And just a little reminder that with regards to the 2 vocab, absolute maximum basically means the highest y value within the given interval, and absolute minimum simply means the smallest y value within the given interval. And this is, as you can see on my screen at the moment, this is just like the fancy definition of what these two really means. So you can just take a minute and have a read through them. So what we're going to do today is I'm going to show you a quick and easy method to handle these kind of problem, and without having to physically sketch the graph and trying to find key features and then trying to identify what is the smallest y and what's the biggest y. So let's just have a look at the first question here. So I gave you this cubic function here. It's a positive cubic. And our domain is, or the restriction that they gave us is this, it's only defined over the interval of -1 through to 3. And our job is to find the absolute maximum and absolute minimum values of this function. So the normal way that we can do, which is I don't recommend for you to do, is by doing this method here. So often students will graph the given function with the restriction as how I typed it in red here. And then once they've done that, they will then going to calculate the maximum value, or the local max, and then they will then going to calculate the local min right here. However, though, that does not mean that it's a wrong method to do, but I'm just saying that's just the long way. And also, too, not only they need to calculate the coordinates of this maximum turning point and the coordinates of this minimum turning point, they also need to work out the coordinates of the 2 endpoints as well. So just by looking at this graph here, you can tell that your absolute maximum over this interval will going to be at 3.8, and your absolute minimum over this interval from -1 to 3 will going to be at 1.54 ... for x, and y will be at -0.63 ... So what I'm going to show you now is a slightly different way, which I found much faster to do. So what we're going to do is let's just define our function first. So let's assign f of x equals to this cubic function here. I'll scroll it on top. So my first factor is x minus 2. Whoops. There we go. And then multiply by my second factor as x minus 1. And then multiply by my third factor, x plus 1. Hit enter. So once you've done that, what I would like you to do now is let's first just work out the absolute minimum first by press menu. We're going to go down to number 4 where it says calculus, and is simply this option right here, number 7, function minimum. So the short way to type it is just little f, min. So we're going to instruct the calculator, so please work out the minimum value of what? Minimum value of f of x. So call f of x out by hitting the variable button, and please solve for the value of x, comma x. And as you can see, it will then going to tell you that x is actually equals to -infinity. Because why? The graph, we did not put any restrictions in it, so it goes on forever. So that's something that I don't want you to do. So when it comes to you trying to define your function, like let's go back to this step here. It is strongly encouraged or reminded that you have to put the restriction in by control =sign button, and then we're going to put this given that, and then I'm going to put the restriction in. Can you see if you don't put the restriction in, you're going to end up like what just happened? So it's very crucial that you put the restriction in for me. When you define your function. So I've defined my function there. And what I'm going to do is let's just copy and paste this entry down again. And as you can see, once you've actually gave the restriction, it now output a x coordinate in for you over this domain. So what you can do now is we would like to substitute this x coordinate into f of x to work out the corresponding absolute minimum. So in order for you to do that, I would like you to hit f of x, and we're going to go up, and we're going to copy down that previous answer, but just keep in mind to edit this a little bit. So get rid of the equal sign, get rid of the x, hit enter. So there we go. You can output the corresponding decimal if you want. So my absolute minimum will going to be when y is negative 0.63 ... which corresponds to this value right here. So that's how you find the minimum. So we're going to do the same thing for maximum now. So I would like you to hit menu, and then number 4, calculus, and number 8 where it says function maximum, and then function maximum of what function? So of f of x, and then please work out or tell me the x coordinate, meaning comma x. Hit enter for me. So the absolute maximum will going to be at x equals to 3, but our interest is to work out what the y coordinate is. So what do? You go f, obviously put 3 in for me, enter, so it spits out as 8, as expected right here from earlier. So that's a very easy and straightforward, just knowing your fMin and fMax. That's pretty much all. So I'm going to show you one more question, and then I'll leave them. There's another question after this as well, and I'll leave that last question for you to try. So it says a model for the amount of medication after X days can be modeled by m of x equals to the product of your your power function here, 2x to the power of a quarter, times it by e to the power of negative 0.1x at 4 over this domain from 0 to 5. So we're going to repeat the process again. So I'm going to first define my function. So let's just type m of x, assign this to be 2x to the power of, get the fraction template out, a quarter. And then what I normally do is get out of the power, please, by just hitting the right navigation button. Multiply this by the exponential, e to the power of negative 0.1x, and then get out of the power, plus 4. Like what I said before, when you're trying to assign your function, it is very important that you put in the restriction. Otherwise, it will going to spit out as an infinite answer for you, which is something you don't want. So we're going from 0 to 5. Hit enter. So that's nice and easy there. So now repeat the same, the similar process. So let's find the minimum function. Menu for 7. All right, and then of who? Of m of x and comma x. So the x coordinate will going to be at 0. And then we need to, that's not our interest though. Our interest is obviously to work out what is the absolute minimum value. So what do? You go m of 0, and the calculator should spit out that the absolute minimum value of my medication here will going to be at 0.4. So meaning, how would you translate this? So the minimum amount of medication will going to be where? At the start. And then because that's when time is 0, and it will going to deliver 4 units of medication. So now let's have a look at the maximum. So this time I'm just going to type it. So fMax, because I know my syntax, of who? Of my m of x, comma x. So therefore the maximum, right? So this is the absolute maximum value of medication will going to be delivered at after 2.5 days, and we would like to work out what will the amount of medication. So what do? You go m 2.5, enter. So the absolute maximum amount of medication that can be administered to a patient from 0 to 5 days will going to be at 2.5 days. And the amount of medication, if I were to round this, say, to 2 decimal places, it will be 5.96 units of medication. So that's all there is to it, nice and easy. So I've got a second question for you as well here about the height of a ball and all that kind of business, which is question 2. So if you're going to repeat what I just did and obviously assign h of t equals to this negative quadratic function, don't forget to put in your restriction. And then you're trying to find the maximum height. So all you got to do is just fMax and then do the syntax. And you should find that your answer will be option A, meaning at 2 meters high. And that is the end of my tutorial. Thank you.